All right, today we are going to talk about lesson 721, and that is what can congruent triangles tell me? And we're going to be working with special quadrilaterals and proof in this chapter, okay? In earlier chapters, we have studied relationships between the sides and angles of a triangle and solved problems involving congruent and similar triangles. Now we're going to expand our study of shapes to quadrilaterals. Remember, quad means four, so four-sided shapes. What can triangles tell you about parallelograms and other special quadrilaterals? Okay, so in this first question, 7-49, Carla is thinking about parallelograms and wondering if there are as many special properties for parallelograms as there are for triangles. She remembers that it is possible to create a shape that looks like a parallelogram by rotating a triangle about the midpoint of one of the sides. So I have patty paper here. I have a triangle to start, 3 different angles shown, so a scalene triangle. I found the midpoint of one of the sides and I'm going to rotate it around. Oh, that's not really the midpoint. Yikes, we'll have to pretend that I found the midpoint. Rotate it around the midpoint. If it was the midpoint, those 2 end points, those angles would match up. And now what we have is this picture right here, okay? Now, is Carla's shape, or is my shape, truly a parallelogram? Remember, the definition of a parallelogram is a quadrilateral with opposite sides parallel. You should be writing this down with me. Okay, you should have this picture. If you need to write down, like, how did we get this quadrilateral from this triangle? We rotated it around the midpoint of one of the sides to form a quadrilateral. And remember the definition of a parallelogram. Make sure you write that down, okay? So we have to decide, is this 100%, are we 100% sure that it is a parallelogram? Okay, and I'm gonna say that the answer is yes. The question is, are opposite sides parallel? Okay, when I look at, remember we kind of talked about a Z, I know this is a backwards Z, but the elbows of the backwards Z, we were given that those two are congruent because when I rotated it around, this angle rotated up to there. So those angles are congruent. When you have that Z or a backward Z and the armpits or the elbows are congruent, then they are alternate interior angles. If alternate interior angles are congruent, then lines are parallel. And that's an important thing for you to write down, okay? If alternate interior angles are congruent, then lines are parallel. Okay, so these are all good things to have in our notes. Same thing is true if we went the other direction. So if I turn my paper around, I see a Z this time. Okay, and again, in the elbow of the Z, I have these 2 angles that are the same. Again, that came from this angle rotating around to the bottom. And because they are the same, it means that those lines must be parallel. So the same reasoning, okay? What else can congruent triangles tell me about a parallelogram? Okay, actually a lot of things. Because this bottom side got rotated around to make the top side, those 2 lengths are exactly the same. They came from the same triangle. Because this left side rotated around to form that right side, those are the same length. So one thing we know is that opposite sides of a parallelogram are congruent, okay? The other thing we know has to do with angles. So if I take this angle down here, oops, there goes my marker, and I rotate it around, it became that angle. All right, and we already talked about the blue and the pink, so 1 blue plus 1 pink, 1 blue was plus 1 pink, those have to be the same, okay? So opposite angles are congruent, okay? We also want to remember, I'm going to take out the diagonal for a minute. I'm just sketching this exact same parallelogram. So the top is purple, the bottom right is a combination of pink and blue, okay? And those two angles together, remember, are consecutive interior angles, okay, or same side interior angles. So we already said that these lines are parallel. If lines are parallel, then same side interior angles are supplementary. Okay, so consecutive angles are supplementary. And the same thing would be true about those two. Purple plus pink and blue make 180. Okay, all the way around, because we already said these are parallel sides. So in a parallelogram, these are facts that you are going to need to know. So writing them down right now would be a good idea. Consecutive angles are supplementary, opposite sides are congruent, opposite angles are congruent. These diagonals are cutting the triangle into two congruent triangles. Sorry, cutting the parallelogram into two congruent triangles. That's pretty good for now. So now we're going to do a flow chart. This is 49D and 50. We are trying to prove this conjecture. Since opposite sides of a parallelogram are parallel, then the triangles are congruent. So the given information are these parallel sides. Remember, we always want to start a proof or a flow chart with the given information. For side lengths, okay, I'm going to write the letters with a hat on, or a segment length over top. AB is parallel to, now it's not marked congruent, so I don't want to put congruent. Those arrows mean parallel. Parallel to CD. How did I know that? Well, that was given. The arrow markings told me that. Same thing, AD and BC are parallel. We knew that because it was given, because of the markings. Okay, so my next step is basically saying, if we know that this is a parallelogram, we are supposed to prove that these two triangles are in fact congruent. So let's use some information that we just talked about up here above. Okay, we did say if lines are parallel, then alternate interior angles are congruent. So angle, let's see, AB and CD, that goes with the pink ones. Angle ABD is congruent to angle CDB. Okay, why is that? If lines are parallel, then alternate interior angles are congruent. So we can start using some shortcuts when we use notation. Any if-then statement can be used an arrow to show if lines are parallel, then alternate interior angles are congruent. Okay, and again, that went with AB and DC. That's the Z there. Okay. Then, if I use the other two sets of parallel sides, I have these angles. And again, think of it like if you rotate it and it's a Z or a backwards Z. Find the armpits of that same Z. ADB, angle ADB, is congruent to angle CBD. Same reason, parallel lines. If lines are parallel, then alternate interior angles are congruent. Okay? Remember, you're not going to have to come up with these proofs from scratch, but you will have to be able to do drag and drops. And if you have really good notes, that's going to help you study, or if it's an open note test, it's going to help you do the correct drag and drops for your tests. Okay, so if I just look at one triangle at a time, remember the goal is to prove those two triangles congruent. Right now, I know that those two angles are congruent to those two angles. So I have angle, angle. I need one more side to prove that they're congruent. Okay, we looked at this a lot last week. Side length DB is in both triangles. So DB this time is congruent. I'm putting an X on it because it's the same exact length in both. DB is congruent to DB, and remember that's the reflexive property. When the same exact line is in two shapes, we can call it reflexive. Okay. Now, in each triangle, I have an angle, side, angle. In that order, angle, side, angle. So by angle, side angle, congruence, don't forget to put the congruence down there, I have proved that those two triangles are congruent. Okay, triangle ADB is congruent. We're not using the similar sign, is congruent to triangle. So A to D to B. I use blue and then purple. Blue and then purple, CBD. Okay? And I have a flow chart to help me prove that if a shape is a parallelogram, then the two triangles are congruent.